Once you've got a formula for ever-changing radius, it's time to put your values into the spreadsheet and automate them. First and foremost, type in the constants that you know. These will be your reference points for later. These are just sample values for now. We'll change them. Let's say we start at an outer radius of 0.08 meters, and we've got this much paper. So we're going to need our thickness divided by pi. So once we're here, we're going to enter this as a formula. If you just type in random numbers, they show up as random numbers. For formula, you have to click equal sign. This equals our paper thickness divided by pi. See how we type in pi capital as a function in Excel? There it is, the thickness over pi. Now we'll set dt. 1 second is definitely not an infinitesimal time interval. So let's count by 0.01 seconds. We'll start over here at 0 seconds. And now here we will say our new time equals the old time plus our delta t. Then we'll fill down. Fill down. What happened? Why isn't it working? What do you mean value? It was a good formula. Let's proofread and take a look. This is all right. Our previous time, A2 plus J2. Where's J2? There's J2. It's our delta D. Now what about this cell? Wait a minute. This is A3 plus J3. It turns out that Excel has two types of references. One is recursive, the cell before me, the cell 3 over from the left, and the other is absolute. We want time 4 to come from time A3, but we don't want it to come from J3. We want it to come over here from J2. So we're going to do our formula correctly this time. The way for an absolute reference is with a dollar sign. We want it to be in column J, which is 1, 2, 3, 4, 5, 6, 8 columns over, and cell 2. If we were really insistent that it was 8 columns to the right, we'd put an additional dollar sign here. It won't hurt, but it's not strictly necessary in this case either. Now, when we fill down, aha, time marches on. Now let's practice using formulas. Way out over here on the right-hand column, we've got a reference column just for free fall. Yes, I know we're not actually doing free fall, but let's practice with free fall first to make sure we're doing it right. Formula. I want my initial free fall height to be here, the same as the height of the balcony, and I don't want to have to reset it every time. Now, free fall says, formula, that my new position should be my initial position minus half of 9.81, oh, we all know that, 4.9 times, yes, you have to put the times in every single time, where's our time? Here it is. I'm in S3, so I want A3, and I want that time caret squared. There it is, and we'll fill down. How about we control D to make that a little bit faster? That looks about right for free fall. We'll do something similar for speed, not because we need the practice, but because it'll be real nice to proofread our speed values and make sure that they're lower than our free fall values, but not too much lower. We're now ready to change our radius. The initial amount we unrolled, delta y, is nothing. Our initial acceleration, you calculated already. It's the same as it was in part 1. Your initial speed is 0 because you're not going anywhere and you're not unrolling anything. Now, how much have we unrolled? We've unrolled. That's going to be our initial height plus however much velocity has happened, note that time sign, over your time. And remember, we've got to make this an absolute reference and keep that delta t the same forever, plus whatever, there's that time sign again, your acceleration, there's that time sign again, has accelerated, make this an absolute reference, over that time squared. There's our formula. We have fallen initial height plus initial velocity times time plus 1/2 acceleration times time squared. There we go. And we can fill this down just as soon as we filled the velocity column down. At this point, we need to be clear on the difference between an absolute formula and a recursive formula. When we calculate velocity, we're used to calculating velocity in an absolute fashion that says, look, here, our velocity equals our initial velocity, let's make that an absolute reference, plus our acceleration in free fall, of course, times our time, with downward being defined as positive. And there we go. However, over here, our acceleration is constantly changing. So we want to say that our falling speed equals our previous velocity, not absolute reference, plus whatever we pick up with our acceleration, not over the whole time that the experiment has been running, but over the little bit that's happened in between this time and this time. Of course, those numbers aren't going to be strictly accurate until we fill in formulas for acceleration in terms of roll radius. So we're going to need to set all these up before we can fill down. We're going to need to see how our radius is changed based on how much paper we've unrolled, how the acceleration has changed due to the new radius, how the falling speed has changed due to the new acceleration, and how our actual height has changed based on the falling speed. All of these are going to be recursive formulas saying that my new one is based on what the old one used to be 0.01 seconds ago. Is it the same over 0.01 seconds? No, it's not. But if we've done our formulas correctly, then to a couple of sig figs, they'll be close enough to make an approximation. If you want a better approximation, reduce delta t to something even smaller, and you'll see the numbers change and become more precise. Be careful to write out your formulas algebraically so that you're clear on the difference between t, how much time the experiment has elapsed in seconds, and delta t, how much time has elapsed since your last data point. Also be sure that when you're putting in formulas in line 3 after the initial values that you're setting by hand, you be careful to reference the previous numbers, the old radius, the old unrolling level, rather than creating a formula that references itself by cross-referencing E3, which you're still writing, with H3, which you haven't written yet. Proofread your numbers by comparing them to the numbers in your free fall column. You're expecting the free fall one to fall more and to fall faster than the one that is still unrolling. Enjoy and good luck. One last quick check as you proofread. Have you multiplied with a time sign? Did you include a $sign for absolute reference? Delta t or full running t? Which one do you need? And have you typed your formulas correctly? Good luck!